Hey guys, welcome to the second set of word problems for the chapter linear equations in one variable. Before we dive straight into the rest of the practice questions, I want to give you two quick crash courses on the concepts of percentage and literal equations. What is percentage? Percent, as the name implies, means per 100. So if I say 50%, I mean 50 per 100, and mathematically this can be written as the fraction 50 upon 100 because fraction is nothing but representing parts of a whole. So 50% would be 50 parts out of a whole of 100. Now of course you can rewrite 50 upon 100 further as 1 upon 2 by cancelling out the common factor of 50 from the numerator and the denominator. Alternatively, you could express 50 upon 100 in decimal format as 0.5. So 50% equals to 50 upon 100 equals to 1 upon 2 equals to 0.5. All of these are valid representations of the very same concept of percentage. But then if I ask you, tell me what is 50% of 80? Then you would tell me, well, if 50% is half, and half of 80 means nothing but 40, of course, right? Therefore, when we say certain percentage of something, what we really mean is that certain percentage multiplied that number, because half of 80 equals to nothing but 1 upon 2 whole multiplied by 80 equals to 40. So there are two main takeaways that you need to remember. The percentage symbol represents division by 100, and when I say of, that means nothing but a multiplication sign, but used more contextually in case of percentages under the disguise of of. What is a literal equation? It is an equation which contains two or more variables. So all of the formulas that you've learned in mathematics in school already, such as maybe the area of a rectangle, A equals to L into B, or maybe the Pythagoras theorem, A square plus B square equals to C square. All of these are variables, A, L, B, C, and therefore since each of the two equations contains two or more distinct variables, therefore they can be classified as literal equations. But when you are told, in case of a literal equation, to solve for a variable, let's say in A equals to L into B, I tell you to solve for B. You don't know the value of A or L, so you can't really give me a numerical answer for B. But when I say solve for B, all that it really means is to isolate the variable B on one side of the equation and everything else on the other side. Alright then, let's move on to the final few questions for this chapter. You may need to sometimes read between the lines, visualize what situation is being described, and even filter out some useless data. But think about how the useful information can come together to form a beautiful equation that leads you straight to your answer.
Pause the video after hearing each question and give it a shot yourself before you listen to Bhavya's solution. Question 7.
1 serving of rice provides 4% of the protein a person needs daily. The remaining 48 grams of protein must come from other sources. Find how many grams of protein a person requires daily.
We have been told that 4% of the total protein requirement is fulfilled by 1 serving of rice, and the remaining 48 grams comes from other sources. And we need to find the total protein requirement in grams. So the remaining comes from other sources, but if 4% comes from rice and in total we always have 100 percentage, so the remaining means nothing but 100 minus 4, that is 96%. So we can say that the remaining 96% of the total protein requirement comes from other sources and is 48 grams. So 96% of the total protein requirement equals to 48 grams. And the total protein requirement is exactly what we need. Therefore, we can simply solve this equation. 96% can be represented as 96 upon 100. We have got the equation 96 upon 100 whole multiplied by total protein requirement equals to 48. Transposing 100 from being in the denominator on the LHS to going into the numerator on the RHS, we have got 96 into total protein requirement equals to 48 into 100. We can also transpose 96 from the numerator in the LHS to the denominator of the RHS. Thus, we have total protein requirement equals to 48 into 100 whole upon 96. We can calculate this, of course. So we've got 48 and 96, which have the common factor of 48, which can be cancelled out from the numerator and the denominator of the RHS. Therefore, the RHS simplifies to 1 into 100 upon 2. Therefore, the equation is now total protein requirement equals to 1 into 100 upon 2. Now 1 into 100 is nothing but 100, 100 upon 2, 100 divided by 2 of course is 50. Therefore, total protein requirement equals to 50 grams.
Question 8.
Ivan works as a salesperson for a marketing company. The position pays £300 per week plus 10% of his total weekly sales. If he earns £550 in a week, then find how much his total weekly sales are.
This is a really straightforward question actually, because the equation is pretty much given. 300 plus 10% of total weekly sales equals to 550. Because they've literally given us 300 plus 10% of total weekly sales to be equal to the total earnings of Evan in a week, and they've said that in this particular week he has earned 550 pounds. So we can just equate those two and we get this equation. Now the variable here is the total weekly sales, and that is exactly what the question wants us to evaluate as well. So let's solve for total weekly sales in this equation and we'll have our answer straightforwardly. So we've got 300 plus 10% of total weekly sales equals to 550. Transposing 300 from the LHS to the RHS becomes positive to negative. So we have 10% of total weekly sales equals to 550 minus 300 equals to 250. Now 10% can be rewritten on the LHS as 10 upon 100, and 10 upon 100 can be reduced by cancelling out the common factor of 10 as 1 upon 10. So we now have the equation changing from 10% of total weekly sales to 1 upon 10 whole multiplied by total weekly sales equals to 250. Now transposing 10 from the LHS denominator to the RHS numerator, the equation changes to 1 into total weekly sales equals to 250 into 10. 1 into total weekly sales, of course, 1 being a multiplicative identity. Even if you don't know that term, you know that anything multiplied by 1 gives that itself. So total weekly sales equals to 250 into 10. 250 into 10 is nothing but 2,500. Therefore, we have got the total weekly sales of Evan as 2,500 pounds.
Question 9.
Fahrenheit and Celsius are two common units of measuring temperature. The relation between the two units is F equals 9 upon 5 times C plus 32. Solve this equation for C.
Alright, we've reached a literal equation question. We've got the equation F equals to 9 upon 5 whole multiplied by C plus 32. Now 9 upon 5 whole multiplied by c is nothing but c is being multiplied in the numerator, so we can call it 9c upon 5 or 9 upon 5 multiplied by c. All of that is fine, but when we say solve for c, of course we need to isolate the variable. Let's throw all of the other stuff on the other side. Let's start. Transposing 32 from the RHS to the LHS, we have f minus 32 equals to 9c upon 5. Now we transpose 5 from the RHS denominator to the LHS numerator. Let's also simultaneously say that we transpose 9 from the RHS numerator to the LHS denominator. After applying both of these operations, the equation we get is left bracket f minus 32 right bracket into 5 upon 9 equals to c. Now you can choose to open up the brackets using the distributive property of multiplication, that's to say multiply f individually with 5 upon 9 and then minus 32 with 5 upon 9 and open the brackets up. But even if you don't do that, I'm perfectly alright. But what I want you to have been able to reach to when we said solve for c in this equation is this: c equals to left bracket f minus 32 right bracket into 5 upon 9.
Question 10.
A jar contains red, white, and blue balls. 1/5 of the balls are red and 1/4 of the balls are white. There are 20 red balls in the jar. Calculate the number of blue balls in the jar.
We've been asked to calculate the number of blue balls, except that we don't even know its proportion in the total number of balls. But let's try to work with the information that we have and hopefully we'll get somewhere. We've been in quite some information about red balls, that 1/5 of the total number of balls in the jar are red and that there are 20 such red balls. So can we equate those two pieces of information, string them together and say this: 1 upon 5 whole multiplied by total number of balls equals to 20? Yes, and solving this equation, we will get the total number of balls, which is not the final answer, but which is an additional piece of information that might help us later on in cracking this question. Let's solve it. Transposing 5 from the LHS denominator to the RHS numerator, we have 1 into total number of balls equals to 20 into 5. Therefore, total number of balls equals to 100, quite clearly. Now, if we drill down to the basics of this question, what it really said is that there is a jar which contains red, blue, and white balls. So can we see this? Total number of balls in the jar equals to red balls plus white balls plus blue balls. And in place of total number of balls in the jar, we can put in the number 100 that we just found. In place of number of red balls in the jar, we can put in the number 20, which is given in the question itself. We don't know the number of blue balls in the jar, but that's exactly what the question wants us to find. And the number of white balls can be thought of as 1/4 of the total number of balls as given in the question, which is nothing but 1/4 of 100, which is 1 upon 4 whole multiplied by 100 equals to 100 upon 4 equals to 25. Thus, this equation becomes 100 equals to 20 plus 25 plus number of blue balls. Now we can simply transpose 20 and 25 from the RHS to the LHS. Thus, we have 100 minus 20 minus 25 equals to number of blue balls. Calculating this, we get 55 equals to number of blue balls. Therefore, there are 55 blue balls in this jar. With that, it's time to put a close to the first chapter of the Math by Year project, linear equations in one variable. I tried to give you a thorough and rigorous and conceptual understanding of the entire chapter, but if there is any feedback you have, anything you might want me to change, some aspect you think I need to work more on, compliments, critiques, and comments of all forms are really welcome. So, comment your doubts below, subscribe for more, share this with your friends. Catch you in the next one.